Welcome to this session of the Highway Capacity Analysis video series. This is the second in a series of 5, and this one is going to try to answer the question, why would you want to attend training to learn the details of the procedures? The point of this is to give you some information about what training includes and why it's helpful to you in performing your analyses. The questions we're going to try to answer are, do you understand the procedure and all the details that are necessary to do your analysis correctly? Is that really necessary when you're using software, since you're really just coding things into fields? And do you know what the software can and cannot do? The procedure details are very important when you're coding software, because you want to know what those fields really are asking for, and you want to know how they're used and what the report really says. Where do those numbers come from? And knowing what the software can and cannot do, a good example is multiple period analysis and signalized intersection, very vital for congested signals and not always implemented. The Highway Capacity Manual Release 6th edition and the Highway Capacity Software Release 7 implement the latest procedures in the manual, all the procedures in the manual, as updated by the committee, who meets twice a year and makes changes almost every time, and the software is kept very current and faithful to the manual procedure. The detailed methodologies for each analysis, you have 14 computational chapters in uninterrupted flow for freeways and highways, interrupted flow for intersections and arterials. Many steps are affecting the results, and you need to understand why all those fields are in there, what each is used for, what's important, what's not as important, and tweak everything you can to get the best answer as possible. So freeway and highway segments and facilities, you want to know how the flow rate is computed from volume, peak hour factor, heavy vehicle adjustment factor as a function of grade. Free flow speed is adjusted for lane width and lateral clearance and access point density, or ramp density. Travel speed comes from knowing the flow rate and the free flow speed, and density that determines level of service comes from knowing the flow rate and the travel speed. So that's the way it's built through the process. With stop, control, and roundabout intersections, the main thing there is critical headway values and conflicting flows. If you're at a stop sign, there are certain movements that you must yield to. You sum those movements and their flow rates, and that's your conflicting flow. Critical headway is how much time must you have before you pull out between vehicles, what's the gap, and how does that vary with different situations. Signalized intersections, a lot more information that you need to do this correctly than just turning movement counts. You need to know things like bus stops and percent heavy vehicles and pedestrian and bicycle counts, parking maneuvers, all affect the saturation flow rate at the stop bar. And all those adjustments, you need to understand how they're used and why they're used. And what the software does is give you access to every little coefficient within those equations so you can get it right. A bus stop defaults to 14 seconds, and your average bus stop might be 45 seconds. Effective green time, how much green is actually processing vehicles and how much is lost. How much of the yellow time is actually used as green. Multiple period analysis, almost it is imperative to do a congested signal so that you can compute delay correctly, get the unmet demand from period to period as they build and dissipate over time. Access points, the same way. Access points affect the platoon between signals, and your ability to model that effect allows you to model what's really out there instead of pretending that no one's interfering with those platoons. The phase duration model gives you the average phase length of actuated phases over 5 or 10 or 15 cycle lengths in a 15-minute period. That's required to convert saturation flow to capacity. And the flow profile is the detailed, intricate procedure from Transit 7F that predicts the proportion arriving on green, modeling the platoon from the upstream signal to the one you're analyzing. So again, the interface for the highway capacity software, the streets module allows you to do a signalized intersection isolated, multiple signals along an arterial, the segments between those signals, the facility as a whole for a given arterial if it had 5, 10, 15, or 20 signalized intersections, interchanges controlling traffic to and from the freeway, and alternative intersections. Two-way stop control and always stop control are built into the stop module. Simulation. You may not know this, but we just developed a partnership with Caliper Corporation, and now Transmodeler is integrated with HCS, gives you access to Transmodeler SE, and with the click of a button you get a quick animation from HCS within Transmodeler, much better than what we've been using in Corsim. Roundabout module, you can do one roundabout or a series of roundabouts including the segments between them. Freeways, all the three segment types, basic ramps and weaving, ramps being merged and diverged, and stringing them together in a facility, again with multiple period analysis for congested operations. The multi-lane highways and the new two-lane highway procedure are implemented. And you may not know that the Highway Safety Manual is implemented in the highway capacity software as a tool. The MUTCD signal warrant procedure is implemented, and we've just developed a turning movement count tool that will allow you to collect arrival demand, not just departure flow, including many of the parameters you need for adjusted saturation flow. So there are other video topics, and you see them there. We just talked about training, but also why is the HCM the best way to go? What is a multiple period analysis? Why is it so important? These access points I've mentioned a couple of times. Why is that so important? How does that work? And why would you choose HCS for optimizing signal timing? Many good reasons for those things too in these other videos. There's contact information for me right there. Please let me know if there's anything I can ever do to try to help compare HCS with something else that you might be using, or in any other way. Just give me a call, shoot me an email. Thanks so much for coming. Thank you.